to do a quick recap of what we just started Equilibria, okay? And we did equilibrium constants. So one very quick recap is there was a thing called the ionization product of water, okay? What that was, if you have water, it tends to ionize. Okay? Everyone knows that water ionizes. And when water ionizes, it produces two ions. One is H plus one and the other one is OH minus one. ठीक है मैं पूरा quick recap कर रहा हूँ. Now, the actual reaction is not this one. This one is a simplified reaction of what goes on. What actually happens is that two water molecules, they collide. One of the water molecule loses its H plus one ion. Okay, it loses the H plus one, it becomes an OH minus one ion. And where does the H plus one go? The H plus one goes and attaches to the lone pairs of the other water molecule. And therefore, the actual equation, okay, water can you don't really have H plus one ions. What you actually have is an H plus one that is attached to some other water molecule. So that's called an H3O plus one ion. So this thing over here, okay, that is what is often referred to as your H plus one aqueous. Okay, this is the actual equation. So anyway, so this is what I told you that H plus one aqueous and H3O plus one aqueous, it's kind of the same thing. Okay, both of these reactions are kind of exactly the same. Now, what I then explained to you was that there's an equilibrium constant, which is product concentration divided by reactant concentration. Water ionizes, so your equilibrium constant is what? It's basically the product concentration. Ek second, then I'm losing my internet. Just 1 second. Just give me 1 second. वो टैब डिस्कनेक्ट हो गई है. Mole per dm cube is a very small value and it is kind of hard or difficult to plot it on a piece of graph paper. वरना और कोई मसला नहीं था. The only reason we're going into log is that if you want to figure out कि भाई soil के अंदर how is the H% concentration varying over time, now that's a really, really small value. So it's hard to plot on a piece of graph paper. So what you do is you take the log of that. Okay, so pH is what? pH is the negative log of 0.001. And if you do that, so log क्या करता है? It just converts it into powers of 10. So what is this? This is actually 10 power minus. What is this? This is actually 10 power minus 3, right? So log just converts that into powers of 10. So log of 0.001 would give you minus 3. But since graphs के लिए we don't really like negative values, what we do is, the reason we're multiplying it with a negative sign is, it's just to convert that into a positive value. ठीक है, वरना log otherwise would have given us minus 3. It's very easy to plot 3 on a piece of graph paper. It's very difficult to plot 0.001 on a piece of graph paper. So the only purpose of taking the log was, ये value बहुत छोटी थी, ठीक है? It's not easy to plot this. So you take the log. ठीक है, ये clear है? So that's what pH is. Is this clear?
Yes, sir.
Yes.
And similarly, we have for bases, for strong bases, if I have NaOH, NaOH is a strong base, it's going to fully dissociate and it's going to produce OH ions. And let's assume its concentration is 0.001 mole per dm cube. But it's going to fully dissociate, ionize. So that would be mole per dm cube as well. The OH ion concentration would be exactly the same. Now, the trouble over here is, in the case of a base, I don't know what the pH is because I don't know what the H plus 1 concentration is. I don't know that. But in the case of a base, I do know the OH ion concentration, which is point, in our case, 0.001 mole per dm cube. Now, यहाँ पे ना, what you have to do is you have to do some extra calculations. And those extra calculations are, since you don't know what the OH ion concentration is, we know Kw, we did it at the start. We know that the ionic product of water, which is Kw, that's 1 times 10 power minus 14. So what we can do is, so normally people don't really like OH ions, they just track H plus 1, ठीक है? H plus 1 ज़्यादा है, तो it's automatically understood what is happening to OH ions. So normally we just track one thing, which is pH. So what we do is we calculate the H plus 1 concentration because we know that the ionic product of water is 1 times 10 power minus 14, but only at room temperature. Since I already know what the OH ion concentration is, that's 1 times 10 power minus 4. 0.0001 is 10 power minus 4. And this is 10 power minus 14. I will figure out the H plus 1 concentration using that. So that's 10 power minus 14 divided by 10 power minus 4. And that's going to give me 10 power minus 10. And now I know what H plus 1 is. So hoga ye ki in the case of a base, you're not going to focus on the OH ions. What you're going to do is you're going to use the ionic product of water and you're going to try and figure out what H plus 1 is. Once you know that, so kya karna is you just take the negative log of H plus 1 concentration, which is going to be the negative log of 10 power minus 10. Okay, that's what your pH is. Or your 10 power minus 10 ka log kya hoga? That's going to be minus 10. And since there's a negative sign, so that's going to give you 10. So the pH is going to be 10 for this space. Okay, now the only thing is that I explained to you that everyone is tracking H plus 1. No one really cares about, I mean, OH ion is equally important. Okay, but just for convenience, everyone is talking about H plus 1 ions. Okay, if the H plus 1 ions go up, then it's automatically understood that you're going to have fewer OH ions. If it's acidic, then it automatically everyone understands that the OH ions are going to be lesser. If the H plus 1 ions go down, then it's automatically understood that the OH ions would be having a higher concentration. Okay? So basis ke andar, this is how you're going to calculate the pH. Okay? So remember what pH 10 means? What pH 10 means, कि जो H plus 1 है ना, its concentration is going to be 10 power minus 10 mole per dm cube, which is going to be very less, and which is understandable because it's a base. You are in a basic solution. In a basic solution, you don't have a lot of H plus ions. You have a lot of OH ions, but you don't really have a lot of H plus ions in a basic solution. ठीक है? ये clear साहब करो मैं सर मिनल हाला, is this clear? Ibrahim, clear है?
Yes, sir.
Same.
अच्छा,
Yes, sir.
so just remember that we are all tracking what is happening to pH. ठीक है? And there are two ways of और इसका भी मैंने बताया था, there are two ways of doing that. You can either use this expression, or you could do the other one as well, which is the other way of solving this is that the other way of solving this is that instead of using that one, you could have taken the log expression, which was what? It was pH plus POH equals 14. उसकी logarithmic version थी, ठीक है, of the same expression. of the same expression. That was the log version, which was basically uh but the pH क्या होता था? It was minus log of H plus 1 and minus log of OH ions. And this was what? Minus log of 10 power minus 14, right? So it was the log expression or the log version of the same expression. So what you could do is you can calculate POH directly initially. OH ions given, and so what you can do is you can calculate POH. And that's going to be minus log of 0.001, which is going to give you 4. Then you go below, you know what POH is, which is 4. And therefore your pH would be, which is going to be 10. So वो जो 10 हमने पहले निकाला था ना, what you could do is there are two ways of doing that. You can either use the expression this one, or you could use the pH plus POH expression, which is this one, which is the same expression, but in terms of log. Both of them are going to give you the same exact value, ठीक है? So is this part clear?
Yes.
Yes.
अच्छा, अब ये कि I'll do a few more questions just for practice, ठीक है? So just remember H plus 1. The main जो चीज याद रखनी है, that's H plus 1 times OH ions. That's the ionic product of water, which is 1 times 10 power minus 14. And the unit is mole squared, DM minus 6. And the other one is the log expression, which is pH plus POH equals 14. Achha, so let's do another one. I'm going to do a slightly reverse question, which is that there's a base which is KOH. The pH is already known. The pH is 12.5. ठीक है? ये कोई calculator ready रखे, ठीक है? Minal, keep your calculator ready. As the pH is 12.5. And they're asking us to calculate KOH concentration. Square brackets is concentration, okay? So what is the concentration of that? Now, since we are dealing with a base, what is more convenient is not pH, because pH to acids के लिए होता है, या H plus 1 के लिए होता है. What is more convenient is that you deal with POH. So we're going to try and find what POH is using the expression which is pH plus POH is equal to. So the pH is 12.5. So my POH is going to come out to be equal to, कितना हो जाएगा? That's going to be 1.5, 14 minus 12.5. Now, POH is what? It's negative log of the concentration of OH ions. But the P, remember that P stands for negative log, ठीक है? ये बड़ा बड़ा लिख भी देते हैं. P, what P means is it means negative log. And that's coming out to be 1.5. तो इसका वो inverse log, वो क्या करता था? 10 की powers में करता था. The opposite is that the OH ion concentration would be 10 power minus 1.5. ठीक है? I mean, you have to practice this a lot. If you see POH is equal to 1.5, that means the OH ion concentration, ये 10 की power है, ठीक है? That's 10 power 1.5, but since you were using a negative sign, you have to incorporate the negative sign back. ठीक है? So make sure you know this, that if somebody says, if somebody says that the pH is 2.5, then automatically understand that the H plus 1 concentration is 10 to the power minus 2.5. ठीक है? ये log और anti-log है. Vice versa, if somebody is trying to calculate the pH, then that's going to be, या तो calculator के अंदर input कर लो, ठीक है? But the inverse, make sure you understand what the inverse is. If somebody says your pH is 3.4.5, yeah, 4.8, then that would mean that the H% concentration is 10 to the power minus 4.8. Okay, so make sure you remember that. So if somebody says your POH is 1.5, learn how to go back to your OH concentration. मैं तो वापस reverse में I'm going to explain this, that if you see pH equal to 3, right? But at 10 power minus 3, था ना? So the reverse is it's 10 to power minus 3, right? If you want to go from H plus 1, if you want to go from pH all the way back to H plus 1. If someone says your POH is 4, ठीक है, or 10 power, so that means the OH concentration is actually 10 power minus 4. ठीक है? So make sure you know how to go back. Once you take the negative log, how to go back. ठीक है, कोई कहता है pH is 13, right? So what does that mean? It means that your H plus 1 concentration is in that case, your H plus 1 concentration would be 10 power minus 13. So keep this in mind. कि reverse किस तरह करना है. I say anyways, going back to the question. Question the pH was given 12.5, right? Based on that, pH plus POH is equal to 14. We were able to figure out because pH was given, and since हम एक base की, we are talking about a base. The important thing was, since we are talking about a base, the important thing was okay, the pH is not going to be that important. The pOH is going to be more important because we're more concerned with OH ions, right? Base के अंदर तो OH ions होते हैं. So we were able to figure out pOH, which is 1.5. We took the inverse, and OH ions would come out to be 10 power minus 1.5. Now I know my OH ion concentration. All I need to do now is I need to find my KOH concentration. So since KOH is a strong base, so 1:1, so this is also going to be exactly the same. Okay, is this thing clear? ये clear है? हाला middle room is this clear?
Yes.
अच्छा एक और question कर लेते हैं. We've got an acid. HCl कर लेते हैं. I've got so HCl and it has a pH of 2.1. And they're asking, it's a strong acid, so they're asking find the HCl concentration. अब ये easy है कि you know the pH, right? So what is the reverse? What is the H% concentration then? वो क्या होगा? If the pH is 2.1, that means the H% concentration is going to be 10 power minus 2.1. इसको जरा कोई calculator पे figure out करो कि what is 10 power minus 2.1? Middle, what is 10 power minus 2.1?
Sir, 7.943 times 10 to the power minus 3.
7.943 times 10 power minus 3?
Yes.
ठीक है. अच्छा लेकिन ये सबसे ज़्यादा मेन कंफ्यूजन होती है. ये चीज़ क्लियर है ना कि this is the log of this, ठीक है? You take the log, which is basically expressing the number in the powers of 10, ठीक है? और ये आप वापस आ रहे हो. ठीक है? If you see pH 2.1, that means H plus 1 is 10 power minus 2.1. ठीक है? So you figure out H% concentration. Now it's pretty easy. Okay, you've got HCl. It's a strong acid. That means it will fully dissociate. It's going to produce H plus 1 and Cl minus 1. And if H plus 1 concentration is 7.943 times 10 power minus 4 mole per dm cube, then the HCl concentration would be exactly the same as well. Okay, is this clear?
Yes.
It's going to be exactly the same. Because एक और कर लेते हैं इसका ताकि just to get a hang of it, ठीक है? We've got so I've got 0.15 mole per dm cube sulfuric acid, and let's assume it fully ionizes. I said, remember, we haven't even touched weak acids yet. I said, and they're asking us to figure out what the pH is. Well, I've got sulfuric acid and it fully ionizes, and if this is 0.15 mole per dm cube, then this would be, uska double ho jayega, it's going to be 0.3. It's going to be 0.30 mole per dm cube, assuming it fully ionizes. Now, pretty easy to calculate pH. You know the H percent concentration. What is pH? pH is the negative log of the concentration of H plus 1, which is 0.3. So, what is the value if you take the log of 0.3? Well, you would have to use the calculator here.
So 0.52.
Because the pH is 0.52. और वही अगर वापस जानो ना, what is that? What is H plus 1? That's going to be 10 power minus 0.5. वो देखो वापस आता है कि कोई चीज आती है कि नहीं आती. What do you get if 10 has a power of minus 0.52?
0.30, yes, sir.
वही ना, ठीक है. तो बस अगर if you're not familiar with log, just make sure कि you know कि pH क्या है. You take the log of that. It's a button on the calculator. pH से वापस जाना है, you just have to take that number, उसको उसकी power पे डालो, except you put a negative sign on it, right? So ठीक है, that's pH, POH, H plus 1, OH ions, right? So we are just tracking up his. I'm just going to recap everything one more time, which is the main चीज ये है. Water, the ionic product of water is a constant. So either you take the log version or the normal version, they both are exactly the same. If you know H plus 1, you would figure out OH ions. If you know OH ions, you would figure out H plus 1. If somebody says to calculate pH, you just take the negative log of that. If somebody says to calculate POH, you take the negative log of that. वापस जाना है pH से, तो just convert the value back into powers of 10. ठीक है. POH अगर 1.5 है, you want to figure out OH ions, that's 10 to the power minus 1.5. ठीक है. I said anyways, so that was the first basic thing. Now the trouble starts with weak acids. So the problem with the ones that we are doing above, the good thing was that it was pretty easy because assuming sulfuric acid was fully dissociating, right? So you had the concentration of the acid, you would easily figure out the concentration of the H plus 1 ions. And therefore you were able to calculate the pH directly because it was fully ionizing. HCl was fully ionizing. You had HCl concentration, the H plus 1 concentration would be exactly the same. So you didn't have to do any extra working. So now the trouble with weak acids is they don't fully ionize. That's the first thing. Okay, they don't fully ionize. They only partially dissociate. Okay, they only partially dissociate. Now, ये problem होगा. For example, if I have ethanoic acid, right? Now, the problem with ethanoic acid is they're going to dissociate, but partially. So, if I have 0.15 mole per dm cube ethanoic acid, and I want to figure out how much H plus ions are present in the solution, right? That is not going to be 0.15 mole per dm cube. That is going to be, normally weak acids dissociate very less. So it's actually going to be very less than 0.15 mole per dm cube. It's not going to fully ionize. So the trouble now is, if you don't know what H% concentration is, right, then you can't figure out what the pH of the solution is. And you can't really figure out the ratio of H+1 and OH ions because you don't know how much it's going to dissociate. Okay? So that's one major issue with ethanoic acid dissociating. And that applies to all weak acids. ठीक है अभी तो खाली वो कर लेते हैं तो पहला तो issue है कि it's kind of complicated to calculate the pH of a weak acid because you don't even know how much H+ ions are going to be produced. And what are your weak acids? Most organic acids are weak acids, right? All acid salts. I'm going to explain acid salts tomorrow. So you've got these things which are weak acids. Mostly it's your acid salts and your organic acids that are weak acids. So what do you do over there in that case? As the good thing is that an acid dissociating weakly is an equilibrium reaction. And if it is an equilibrium reaction, that equilibrium will have an equilibrium constant. It's going to have product concentration divided by reactant concentration. Okay? So यहाँ से for weak acids, there's an equilibrium constant which is known as the dissociation constant. Okay, so we did Kw earlier, we did Kw, which was the water dissociation constant. Now we're going to do Ka, which is a weak acid dissociation constant. So that will help us figure out what is the amount of H+ concentrations that are going to be produced when a weak acid dissociates. Okay? So we'll discuss that tomorrow. ये clear है Ibrahim Rumesa? Hala, is this clear up till this point?
Yes, sir.
Yes, sir.
ठीक है तो फिर वीक एसिड और के वगैरह ना फिर केडब्ल्यू भी हमने पढ़ा था ठीक है केडब्ल्यू लेकिन काम करता है सिर्फ और सिर्फ स्ट्रॉन्ग एसिड्स के लिए क्यों ना फुली आयनाइज होना होता है H+1 पता लग जाता है OH आयंस पता लग जाते हैं तो वो केडब्ल्यू इस्तेमाल करके ना इट्स वेरी इजी टू फिगर आउट pH and POH but for weak acid there's an extra step which has to be done. We'll discuss that tomorrow. ठीक है okay everyone take care. Hafiz.
Okay, thank you, sir. Allah.